Welcome again to Let's Talk Chemistry with Pastor Dan. We're looking at acid-base reaction. Now, an acid-base reaction is a reaction of an acid with a base to form a neutralization reaction. So we're going to eliminate the acid and the base. And we're always going to form water and a salt as a product. So let's take the easiest option here. That would be hydrochloric acid with sodium hydroxide. So HCl is hydrochloric acid. It's binary. It's an ic. It's hydroic, so it's an ide, so hydrogen chloride, and sodium hydroxide, sodium is +1, hydroxide is -1, NaOH. The reaction is going to give us NaCl, double replacement reaction going here. We call it neutralization because it's going to eliminate both the acid and the base, and the other product is H2O. So HCl, because it starts with an H, is my acid. NaOH then has to be my base, all right? And that makes NaCl my salt. And I don't always identify. A salt is not just NaCl. NaCl is any ionic substance that is not an acid or a base. So anything that is not an acid or base that is ionic, we classify as a salt. All right, and then we have the water there as well. Now, there's two different ways we can identify acids. The first was identified by I think it's Swedish, I'm not sure, scientist named Arrhenius. Arrhenius identified an acid as a substance that produces hydrogen ion when it dissociates, and a base is a substance that produces hydroxide ion when it dissociates. Now, what is dissociation? Process of breaking down into its base ions. Okay, now what does that mean? All right, so here we have four different compounds. So we'll start with hydrochloric acid. We break into H plus and Cl minus. I talked about that before when I talked about strong and weak acids. So you see it dissociates that way. We dissociate this one. We're going to get H plus, but I'm going to multiply it by 2. It's not H2. It's not the element. It's the ion. So therefore we have to have 2 of those, and the sulfate's over there. Now let's try the other 2. Let's try the bases. Now they're going to dissociate into Na plus OH minus, dissociate into its ions. And then the last one, once you pause the video and you see if you can do that one yourself, okay? You should get, hopefully, Al3 plus 3 OH minuses. That's the dissociation process. All right, so now a problem came up. There's something like bicarbonate, sodium bicarbonate, baking soda. That's basic, but there's no hydroxide. Ammonia is NH3, also basic, but no hydroxide. So two examples here were created by 2 different scientists. One is, I believe, English, could be Irish, I'm not sure. And the other is German. That's why the little through the O is. They came with the idea at the same time, so we give them both credit for it. For an acid and base for them, substance that donates a proton is an acid, and a substance that accepts a proton. Well, what do we mean by accepts a proton? Remember, we said hydrogen ion is an acid. All right, hydrogen ion. Well, if it's a hydrogen, it's 1 proton and 1 electron, but it's an ion. It's charged. So therefore, that electron is away, so all we're left with is a proton. So therefore, hydrogen is a proton. Same thing. So a proton donor, acid, proton acceptor, base. All right, so let's try this reaction. We have Hi plus CuIO2. Now, when we do that, we're going to get double replacement, CuI2 plus H2O. That's basic reaction. Hi is my acid because it starts with an H. CuOH twice is my base. And my salt is Cu. I don't have to identify water there. We know water, okay? Now, for the second one, okay, we're going to get Zn with CrO4, zinc with chromate. So that's zinc chromate and water. Okay, and my acid is going to be this time the H2CrO4 chromic acid, and zinc hydroxide. Hydroxide is my base. My salt is a zinc chromate. All right, now, there's balanced up. All right, now we do have to identify weak and strong acids here. When we have a weak, and remember we talked about acids and bases, a base is strong. If it has hydroxide, it's weak. If it doesn't, acids, remember we said binaries are strong bases. We're going to assume that's not always the case. We're going to assume that. And then for polyatomics, for 8s and 9s, it's number of oxygens minus number of hydrogens 4 greater. If we have either of them weak, either one, the acid weak, the base weak, or both, we end up with an equilibrium reaction. When we do that, we have a conjugate acid because the reaction is coming back. So what is a conjugate acid? Conjugate acid is one that acts as the acid in the reverse reaction. Well, remember the reverse reaction is a salt and water, and an acid is one that starts with hydrogen. So which one starts with hydrogen? Water. Just about always, I don't want to say always, but just about always, water is my conjugate acid. And my conjugate base, in the reverse reactant acid base, what's left is a salt. So the conjugate base, just about always, is my salt. All right, so let's try this one. Okay, in this situation, we have the NaOH as my base, and it's strong because it has hydroxide. Acetic acid, that's hydrogen acetate, acetic acid, 8 acid, that's my acid. It's weak. Why? Because 2 minus 4 is minus 2. That's definitely less than 2, so it's weak. So we end up with an equilibrium reaction going forward and backwards. Okay, so the first product is going to be sodium acetate, and that's water's the second one. That's my salt, and that's going to be my conjugate acid because coming back, it's going to start with hydrogen ion, and that means that my conjugate base is the sodium acetate. All right, let's try this one then. Copper 2 carbonate plus nitric acid, okay? My copper 2 carbonate is my base. It's weak because it doesn't have hydroxide. My nitric acid is my acid. It is strong because I have 3 minus 1. Because one or both are weak, it's going to be equilibrium. So we're going to put C with NO3, and we remember, swap them down. It's plus 2 minus 1. And we have H2CO3. Now, wait a minute. I thought you said you always had to have water. Well, we do. That's carbonic acid. When carbonic acid forms, balance it up, sorry, we spontaneously break down into water and carbon dioxide. So there's my water, and that carbon dioxide is going to bubble off. So therefore, my salt is my copper 2 nitrate. My conjugate acid coming back is going to be, now we don't always have conjugates, only if it's equilibrium, and my conjugate base is going to be my salt. All right, let's try this last one. Pause the video, give it a shot, see what happens. Okay, hopefully you see that they're both strong, my base and my acid, therefore it's going to be a direct reaction. That means no conjugates here. We're going to get AlFO3 3 times, balanced up, and then it's my salt. I have no conjugates because it's not coming back again. All right, so try these two, give it a shot, pause the video, see what we come up with. All right, pause it. Okay, here's the answers. Hopefully that wasn't too, oh, and I didn't balance it. That's what the reason why it was there before, because it's got to be a, oh, no, it is balanced. All right, we're all good. All right, take care. God bless. Have a good day.